Hey, welcome to this lesson video for a continuation of how we create our unit circle. We're going to be looking at the degrees of 45, 135, 225, and 315. So we're going to be able to find the sine, cosine, and tangent of those 4 degrees without using a calculator and just making reference triangles. So before we get started, let's just recall our basic side measures. So if I'm dealing with a 45-degree triangle, 45, 45, 90, and we're talking about the unit circle and our reference triangles, the hypotenuse is always 1, and the sides are radical 2 over 2, radical 2 over 2. Both sides are the same measure. If I have a 30-degree angle happening at the origin, the hypotenuse is 1. Again, this short leg is a measure of a half, and then this longer leg measures radical 3 over 2. Finally, if it's reversed where the 60 degree is in the corner near the origin, excuse me, my hypotenuse is 1. Again, this short leg is a half, and this longer leg is radical 3 over 2. So we just want to make sure that we remember these side lengths as we work around our quadrants and our coordinate plane. Another thing to remember, think about going around the circle. Our 0 degrees is going to start over here near the positive x's, and then we're going to work counterclockwise. We're going to go to 90 degrees, then we're going another 90 to 180, another 90 to 270, and then finally when we go full circle, we're back to 360. Okay, so kind of remember our placement as we go around the coordinate plane. So we're first asked to start with a measure of 45 degrees. And if I think about, what we just talked about, 0 degrees and 90 degrees, 45 degrees falls in the first quadrant, and it actually splits it directly in half. Okay, so this line represents my 45 degrees that I'm asked to find. Okay, now I'm going to drop an altitude, okay, to make our right triangle. And since this guy is a 45 degrees here at the origin, because the difference between 0 and 45 is going to make that angle 45 degrees, using those side lengths we talked about in our first slide, the hypotenuse measures 1. This measures radical 2 over 2, the leg on the axis, and this leg also measures radical 2 over 2. Now, if I'm thinking about, sine, cosine, tangent, SOHCAHTOA, I need to label my sides as opposite, adjacent, and hypotenuse. So obviously this 1 is my hypotenuse. And a little trick that I like to remember, the adjacent side, the A, adjacent, is always on the axis. Okay, so the adjacent is on the axis. And then this leg is the opposite, because it's opposite the 45 degree happening at the origin, which is kind of like our reference angle. So then sine, cosine, and tangent should be pretty easy. To find sine, O over H, radical 2 over 2 divided by a 1 is simply radical 2 over 2. Cosine, A over H, again, radical 2 over 2 divided by 1 is just going to be radical 2 over 2. Now, tangent, O divided by A, I'm going to write this off to the side. Radical 2 over 2 divided by itself. Now you might be thinking, whoa, or you might try to, keep, change, flip. Keep the first fraction, change multiplication, flip the second, because that's how you divide fractions. But just wait a second. What are you dividing? A number divided by itself equals 1. So in this case, my tangent is actually just 1. So don't overcomplicate it. And then this last question says, what is the coordinate point where the hypotenuse touches the circle? So if I were thinking about an ordered pair for this point, what would it be? Well, x comes first, so how many x, distance of x did you go over? We went over radical 2 over 2. Let me change so we can read it. Radical 2 over 2. And then how much of a y value did I go up? I went up radical 2 over 2. Okay, so let's continue and now look at finding the sine, cosine, and tangent of 135 degrees. I just copied my directions up here, and it says 45, but we're moving on to 135. So think about, 0 degrees, 90 degrees, 180. Where does 135 fall? It puts us in the second quadrant. And again, 135 is going to cut this quadrant exactly in half, 135 degrees. Now, if you weren't sure, how did I know that that cuts it in half? Well, if you think about making our triangle, dropping the altitude, I need to know this angle, and this angle is the difference between 180 to 135. So if you find that difference, 180 minus 135, you'll get an angle of 45 degrees. So that's why it cuts it in half. Let's see. So my side measures. So when I think about my side measures, I know that the hypotenuse measures 1. The legs are the same, so this altitude that I dropped measures radical 2 over 2, and this leg along the axis also is radical 2 over 2. However, when you think about the regular coordinate plane, this part of the x-axis represents negative x's, so I want to negate that value. Okay. So again, when I think about 45 as being my reference angle and thinking about SOHCAHTOA, 1 is my hypotenuse, the positive leg is my opposite side, and then the negative leg on the axis is my adjacent. So then I'm just going to run through SOHCAHTOA again. O divided by h, radical 2 over 2 divided by 1, radical 2 over 2. Cosine a over h, my negative radical 2 over 2 divided by 1. It's just going to be itself, negative radical 2 over 2. And then my tangent, I've got O divided by a. So a positive radical 2 over 2 divided by a negative radical 2 over 2. So it's still a number divided by itself, it's just that one of them are negative, so that means my tangent's just going to be negative 1. And when I think about the value at this point where the hypotenuse hits the circle, my x value, I went back radical 2 over 2, so negative radical 2 over 2, comma, how much I went up to reach that point, radical 2 over 2. Okay. So if I keep moving along, I then change to the degree 225. So if I'm thinking 0 degrees, 90 degrees, 180, and 270, 225 falls in this third quadrant. And again, it does cut it in half, but if you weren't sure, since this represents 225 degrees, and when we think about making our triangle, and this angle at the origin is what I'm trying to find, its measure, I would need to consider the difference between 225 to 180 to know that angle measure. So 225 minus 180 would create another 45 degree in the corner. So that's why this 225 cuts that third quadrant in half. So again, labeling my side measures, my hypotenuse is still positive 1. This leg before was negative radical 2 over 2, so that stays the same. And this time, since I'm in the negative y values, this leg is also going to be negative radical 2 over 2. So as 45 degrees at the origin is my reference angle, 1 is my hypotenuse, the side on the axis is my adjacent, and that leaves that side to be opposite. And so again, just running through SOHCAHTOA, O divided by h is just going to be negative radical 2 over 2. A divided by that 1 is just going to be negative radical 2 over 2. And then my tangent, a negative radical 2 over 2 divided by another negative radical 2 over 2 is just going to make it go back to a positive 1. And then this coordinate point, how much I went back and then down, negative radical 2 over 2, that's the x value, and then again, negative radical 2 over 2. All right, so you can see we're just working our way around the coordinate plane with this 45 degree triangle. So we've got one more angle to consider. We know that this is 270, and if we go full circle, That's 360. So 315 is going to cut it in half. And if you're not sure if it cuts it in half or not with a 45 degree, remember we want to think about the difference. This is the angle I'm trying to find. So I'm looking for the difference between 360 and 315. So when you do that subtraction, you do indeed get another 45 degree angle. And so I'm going to label my sides. My hypotenuse is 1. This side is back to being positive radical 2 over 2. However, this is still in the negative y's, so this is negative radical 2 over 2. Okay, so just label OA and H from this angle at the origin. That's my hypotenuse. The side on the axis is adjacent, and that leaves that to be opposite. So then SOHCAHTOA, O divided by H is going to be negative radical 2 over 2. Cosine, though, A divided by H, it's going to go back to being positive radical 2 over 2. And then tangent, my negative O, O is negative radical 2 over 2, divided by my A, which is positive again. So still going to be a 1, but since one's negative, one's positive, it's going to be a negative 1. And so this point where the hypotenuse hits the circle, I went over positive radical 2 over 2 for an x value, but I went down, so my y value is negative radical 2 over 2. So that finishes up our 4 degrees of 45, 135, 225, and 315. Another set of degrees to look at, so you might want to check this video out, looking at 60, 120, 240, and 300. But that's it for this one. Keep learning, and I'll see you next time.